Hello everyone, I'm Dasari Praneeth Sanjay. I'm from JNTU Hyderabad. I'm from Computer Science and Engineering Department, bearing roll number 24011A0560. I will be demonstrating on batteries, and this overview demonstration is being fueled by Assistant Professor G. Raju sir. Further moving on, contents of this demonstration are comparison of batteries like WH battery, AH battery. Secondly, working of lead acid battery. Thirdly, working of nickel cadmium cell. And at last, charging methods of a battery. Formally, there are two types of batteries based on their capacity. They are AH capacity batteries and WH capacity batteries. An ampere hour, abbreviated as AH or sometimes ampere hour, AMPR, is the amount of energy charge in a battery that will allow 1 ampere of current to flow for 1 hour. An ampere is a unit of measure of the rate of electron or current in an electrical conductor. AH capacity. The formula for AH capacity is I into T, where I is the rated current during discharging. T is discharging time in R. Watt-hour capacity. The watt-hour capacity symbolized WH is a unit of energy equivalent to 1 watt of power expended for 1 hour of time. The watt-hour is not a standard unit in any formal system, but it is commonly used in electrical applications. WH capacity. The formula for WH capacity is I into T into V, where I is the rated current during discharging, T is discharging time in R, where V is the average voltage during discharging. We will discuss about the lead acid battery. Working of lead acid battery. Lead acid battery is a secondary battery or a storage battery where the electrical energy can be stored as chemical energy, and this chemical energy is then converted to electrical energy as and when required. The conversion of electrical energy into chemical energy by applying external electrical source is known as charging of battery. The materials used for lead acid storage cell are formerly lead peroxide PbO2. The positive plate is made of lead peroxide. This is dark brown, hard and brittle substance. Secondly, sponge lead. The negative plate is made of pure lead in soft sponge condition. Thirdly, dilute sulfuric acid. It acts as an electrolyte and added in the ratio of water is to acid as 3 is to 1. Next comes the charging and discharging process in lead acid storage cell. Firstly, we'll discuss about discharging process. The lead acid storage battery is found by dipping lead peroxide plate and sponge lead plate in dilute sulfuric acid. A load is connected externally in between these plates. In dilute sulfuric acid, the molecules of the acid split into positive hydrogen ions H plus, negative sulfate ions SO4 minus 2. The hydrogen ions, when reach at PbO2 plate or lead peroxide plate, they receive electrons from it and become hydrogen atom, which again attack lead peroxide plate and form lead oxide and water. This lead oxide reacts with sulfuric acid and forms lead sulfate and water. Sulfate ions are moving freely in the solution, so some of them will reach to pure lead plate where they give their extra electrons and become radical sulfate. As the radical sulfate cannot exist alone, it will attack lead and will form lead sulfate. As H plus ions take electrons from lead peroxide plate and the sulfate ions give electrons to lead plate, there, there would be an inequality of electrons between these two plates. Hence, there would be flow of current through the external load between these plates for balancing this inequality of electrons. This process is called discharging of lead acid battery. The lead sulfate PbSO4 is whitish in color. And further, we'll discuss about charging process in lead acid storage cell. Charging process in a lead acid storage cell. Both of the plates are covered with lead sulfate. Specific gravity of sulfuric acid solution falls due to formation of water during reaction at lead peroxide plate. As a result, the reaction of the rate of reaction falls, which implies the potential difference between the plates decreases during discharging process. Now, we will disconnect the load and connect lead sulfate covered lead peroxide plate with positive terminals of an external DC source and lead peroxide covered lead plate with the negative terminal of that DC source. So during discharging, the density of sulfuric acid falls, but there is still sulfuric acid exists in the solution. The sulfuric acid also remains as H plus and SO4 minus 2 ions in the solution. The hydrogen ions, being positively charged, move to the cathode or move to the electrode, that is cathode, connected with negative terminal of that DC source. Here each H plus ions take one electron from that and becomes hydrogen atom. These hydrogen atoms then attack lead sulfate and form lead and sulfuric acid. So here we can see the reaction. Lead sulfate plus 2H plus ions gives sulfuric acid and lead. The sulfate ions, SO4 minus 2 ions, moves toward the electrode, that is anode, connected with positive terminal of the DC source. Here, the source, the electrons, and become gives the electrons. SO4 minus 2 gives the electrons and become radical SO4. This radical SO4 cannot exist alone. Hence, reacts with lead sulfate of anode and forms lead peroxide PbO2 and sulfuric acid H2SO4. We can see the reaction. PbSO4 plus 2H2O plus SO4 gives lead peroxide PbO2 plus sulfuric acid H2SO4. Here we need to see the applications of lead acid storage cell. They are used in starting batteries for engine starting and ignition applications, EFB batteries for microcycling in start-stop engine technology, float batteries for UPS or telecom or standby backup power applications, cyclic batteries for light-duty lighting and accessory loads in RV or marine applications like marine submarines, renewable energy batteries for long life high cycle use in off-grid applications, industrial traction for heavy duty use in industrial equipment such as electric forklifts. Next we will be discussing about another important storage cell, that is nickel cadmium storage cell. It is also a secondary storage battery. The construction of nickel cadmium battery is very similar to that of nickel iron battery. The construction of a nickel cadmium cell contains a positive plate which is made of nickel hydroxide, NiOH taken twice, and the negative plate is spongy cadmium. A 21% solution of potassium hydroxide KOH is distilled in distilled water is used as the electrolyte. The specific gravity is approximately 1.2. The positive plate are of nickel hydroxide. The negative plates are made of mixture of cadmium and iron. Potassium hydroxide KOH is used as electrolyte in this battery. The internal resistance of nickel cadmium batteries is low due to the use of cadmium. Electrical characteristics are almost same as those of nickel iron batteries. Further, we'll be discussing about charging and discharging of nickel cadmium. Action during discharging or the processes involved during discharge. The electrolyte KOH splits into positive K ions and negative OH ions. During discharging, ions from the negative plate force free electrons to positive plates. When the cell is discharged, the positive element becomes nickel hydroxide, while negative element becomes cadmium hydroxide. Here we need to see the reactions at anode. NiOH taken twice, that is nickel hydroxide, on reacting with potassium gives nickel hydroxide plus potassium hydroxide. At cathode, cadmium plus hydroxide ions give cadmium hydroxide. So the total reaction is given below. Nickel hydroxide plus potassium hydroxide plus cadmium gives nickel hydroxide plus potassium hydroxide plus cadmium hydroxide. So action during discharging. Here we will be looking at charging process involved in nickel cadmium cell. During charge of the cell, the positive element becomes nickel hydroxide and negative element becomes metallic cadmium. When cell is fully charged, it generates oxygen gas at positive element and hydrogen gas at negative element. So the overall charging equation is given as NiOH taken twice nickel hydroxide plus 2 moles of potassium hydroxide plus cadmium hydroxide gives 2 moles of nickel hydroxide plus 2 moles of potassium hydroxide and finally cadmium. So charging methods involved. Firstly, constant current charging method. The completely discharged battery, if first charged at a constant charging rate, this will cause the terminal voltage of the battery to increase considerably. The charging current is kept constant by varying the supply voltage for overcoming the increased cell voltage. The value of charging current is adjusted carefully to avoid excessive gassing. Secondly, boost charging. When the current is being charged for the first time or when it is being used after a long time, the boost charging mode is used, where the cell voltage is raised above 2.4 up to 2.6 volts. The boost charging is used for breaking down the crystalline lead sulfate, that is PbSO4, which is formed when the battery is not in use for a long time. Thirdly, tickle charging. The tickling charging is necessary to keep the battery fully charged always. It is used for compensating the charge lost due to internal discharge of the battery. The tickling charging current is very low. When battery is kept at an emergency service, it is necessary to ensure that it is fully charged all the time and ready for service anytime. The charged battery always loses some of its charge due to internal leakage and other open circuit losses. To compensate for such loss of charge, the battery is kept on trickle charging. And finally, constant voltage charging method. When cell voltage reaches sufficiently high value, the constant current charging is stopped and constant voltage charging is adopted. The charging current then decreases. Typically, the voltage at which changeover from constant current to constant voltage takes place at 2.25 volts. So here we can see the charging modes. When the voltage at charging reaches a point, it obtains a constant voltage value. Similarly, when the charging current reaches a standard point, it then decreases. It is called taper current. So, in this demonstration, we discussed about various storage cells like lead acid storage cell and nickel cadmium storage cell and discussed their applications too. And finally, we winded up by knowing various charging methods. Thank you. This is Praneeth signing off.